6 months into my first reef, I had an algae problem I could not solve. I tested my water. Parameters were good, my skimmer was working, my refugium was growing. Everything looked right on paper. Eventually, I started mapping where all the algae was growing, and it was always in the same places. The back corners of the tank, behind the rockwork, and the bottom rear of the glass. Dead spots. I had dead spots in my tank because I never thought seriously about where my flow was going. The water was moving, but not everywhere I needed it to be. But in those still pockets, detritus was settling, oxygen depleted, and algae was thriving. Water flow is the most underestimated variable in reef keeping. It's invisible and it's silent. When it's wrong, the consequences show up everywhere else, and you spend months chasing the symptoms, not the cause. This is step 4. Water flow in a reef tank does 3 things, and all 3 things are non-negotiable. First, it delivers oxygen and nutrients to every surface in the tank. Corals are sessile, they cannot move toward food. You must bring the food to them. A coral sitting in a dead spot is slowly starving, no matter how good your parameters are. Second, it prevents detritus from settling. Organic waste that settles becomes a nutrient source for algae and cyanobacteria. Flow keeps it suspended until your mechanical filtration can remove it. Third, it oxygenates the water column. Surface agitation drives gas exchange. Oxygen in, CO2 out. At night, photosynthesis stops. If your water isn't moving, oxygen depletes. It's as simple as that. Every flow decision you make, pump selection, placement, flow rate, should be evaluated against these 3 requirements. The return pump. It's not your primary circulation pump. It's your water transport mechanism, moving water from the sump to the display at a rate that maintains your overflow and keeps the system in balance. Sizing a return pump comes down to 2 things: your desired turnover rate and your head pressure. Turnover rate. For a reef system, you want your return pump turning over your total system volume, that's display plus your sump, 3 to 5 times per hour. On a 130 gallon display with a 40 gallon sump, that's 510 to 850 gallons per hour at the pump outlet. Head pressure is where most people get caught out. Every foot of vertical rise, every elbow, every meter of pipe between your sump and your display tank reduces the pump's effective flow rate. A pump rated at 800 gallons per hour at 0 head may only deliver 500 gallons per hour once you account for all of your plumbing. Always check the head pressure curve, not just the headline flow rate. DC return pumps are significantly more efficient than AC equivalents. Most modern DC pumps are controllable. Dial in your exact flow rate without a ball valve. For a reef system, DC is the right choice. Your return pump handles transport. Your Powerheads handles circulation. Powerheads, or circulation pumps, are the pumps mounted inside your display tank. They create the water movement that reaches every corner, every coral, every surface that your return pump flow alone cannot reach. There are 2 main types of circulation pump: propeller style or wavemaker style. Propeller pumps, like the MaxSpec Gyre or the Toons range, create a wide laminar flow pattern. They move a large volume of water in a relatively gentle, broad stream. This replicates the natural water movement over a coral reef, a broad, sweeping current rather than a focused jet. Wavemaker style pumps, like the Ecotech Vortec, create pulsing, randomized flow patterns that mimic tidal surge. The randomization means that corals are never in a sustained dead spot, and the pulsing motion encourages polyp extension. For most reef builds, a combination works best. 1 or 2 Gyre style pumps for broad circulation, with wavemaker mode activated during the day for randomized surface agitation. Gyre theory. This is where most hobbyists stop thinking about flow and actually start engineering it. A gyre is a circular flow pattern that forms when a pump creates a current that travels the length of the tank, hits the far end, and returns along the opposite surface. Done correctly, a single gyre creates circulation across the entire tank volume with minimal dead spots. In practice, a single gyre looks like this. Pump mounted on one short end wall, pushing water horizontally across the length of the tank at the surface. The current hits the far end, deflects downward and back along the bottom, then rises back up near the pump and repeats. A dual gyre setup two pumps on opposing short walls firing in the same direction creates more powerful, more even circulation, preferred for tanks over 100 gallons, or any build with a complex aquascape. The Gyre concept is why long, wide tanks are significantly better for reef keeping than tall, narrow tanks. The geometry supports the Gyre. A tall tank breaks up the circular flow and creates vertical dead spot zones below the rockwork. A tank that's twice as long as it is wide allows a clean gyre to form. A tank that approaches square dimensions, or worse, is taller than it is wide, fights the gyre at every turn. Back to dead spots, because this is where flow theory becomes tank reality. A dead spot is any area in your tank where water movement is insufficient to keep detritus suspended or deliver adequate oxygen and nutrients to your coral. They form wherever the flow pattern is interrupted. Behind rocks, in the corners, along substrate beneath overhang. You can identify dead spots in two ways. The slow way, wait for cyano and algae to tell you where they are. Or the fast way, drop a small amount of fine sand or fish food into the water column and watch where it settles. Wherever it settles consistently is your dead spot. Fixing dead spots comes down to pump placement. If you have a persistent dead spot in the back corner, you either need to reposition an existing pump to direct flow into that area, or add a smaller auxiliary pump specifically aimed at that zone. My dead spot problem, the one I mentioned earlier, was solved by moving one power head from the front of the tank to the rear, angled towards the back corners. 10 minutes. 6 months of algae problems solved in 10 minutes. With baseline circulation established, now zone your flow by coral type. Different corals evolved in different parts of the reef, and those different locations have different flow characteristics. SPS corals like Acropora, Montipora, and Stylopora evolved on the reef crest and upper slope where wave action is the strongest. They require high flow, 50 to 100 times tank volume per hour, across the coral surface. Random, multi-directional flow. No face of the coral sitting in a flow shadow. LPS corals like hammers, frog spawn, torches, and brain corals evolved in calmer mid-reef zones. Moderate flow, 20 to 40 times tank volume. Enough to keep them fed and oxygenated, but not so strong that their sweeper tentacles are pinned and unable to extend. Soft corals, like leathers, mushrooms, and zoanthids, evolved in lagoons and back reef environments with gentle, indirect flow, 10 to 20 times tank volume. Direct, high flow will cause them to close and retract. Position them in flow shadows, behind rockwork or in lower tank zones. This is why your aquascape design and your flow plan need to be created together, not separately. The placement of your rock determines where your high flow and low flow zones are. Your coral placement follows from that. 2 mistakes I made that I want you to avoid. The first, I bought my Powerheads based on the maximum flow rate on the box. A pump rated at 2,000 gallons per hour, running at full power, pointed directly at your rockwork, isn't circulating your tank. It's sandblasting it. I had SPS corals bleaching on one side from direct flow impact, while the other side of the tank had dead spots. Less power, better positioned. That's the fix. The second mistake, I didn't think about flow at night. During the day, my Powerheads were running a gyre pattern and everything looked great. At night, I switched them to a lower power setting to reduce noise. At low power, the gyre collapsed. The broad circulation pattern broke down into weak, localized eddies. I was waking up every morning to slightly elevated CO2 and dropping pH. And I spent weeks blaming my alkalinity dosing before I worked out the real cause. Run your Powerheads at a slightly reduced speed at night, not a dramatically reduced one. The gyre needs to be maintained. Silence is not worth sacrificing the circulation pattern that keeps your tank stable while you sleep. Before I close, these are the numbers you need. Return pump, 3 to 5 times total system volume per hour, measured after accounting for head pressure. That's your target. Total circulation, Powerheads plus return, 40 to 60 times display volume per hour. That's the starting point for a mixed reef. Adjust upward for SPS, downward for softies. Those are the numbers. Work backwards from there. Powerhead placement. Mount on the short end walls aimed horizontally across the length of your tank. Never aim directly at your rockwork or corals from close range. Randomize your flow. Every quality DC Powerhead on the market today has a wave or pulse mode. Use it. Random flow prevents dead spots from forming at the edges of your gyre and encourages natural polyp extension. And revisit your flow plan every time you add significant rockwork or livestock. Your aquascape changes your flow pattern. What worked at setup may not work 6 months later. In step 5, we get into lighting, par, spectrum, and photo period. The one component in your reef system that directly controls the biology of every coral you keep. It's also the component most people spend the most money on and understand the least. If this series is saving you time and money, it'll be a good idea to subscribe so you can follow along for future videos. Every step builds on the last. You don't want to miss this one. Master the ecosystem, and I'll see you in step 5.